All right, we're going to take a look at slices. Now, just as the name implies, it's a slice of an array. So I'm going to go ahead and run this real quick. We have an array here, and we have a slice here, and we're going to go ahead and print both of these off so you can kind of get an idea of what's going on. All right, as you can see, we have our entire array, like we'd expect, and the slice here is just a subsection of that array. It's just right here. Now, you might ask, why would you use a slice anyway? Why not just use an array? Well, slices are going to be a lot less computationally expensive than an array. So if we were creating a new array and we're saving these values over to it, we'd have to save those over into a new place in memory. Now, a slice is actually just a reference to an existing array. So it's just saying, hey, from here to here, this is the stuff I'm talking about. So a reference is very small, and it's almost nothing to save a reference. So, very small, very fast. If you're using Golang, that's one of the selling points. Is Golang is fast. It's pretty close to the metal. So this is one of the advantages you have, at your disposal. So anyway, looking at how this is slicing it. So we have our letters array, and here we're taking a low bound and a high bound, and we're gonna go ahead and grab the elements in between there. So the best way to kind of explain which things it's going to grab, I kind of look at it this way. I start counting before each letter, and then I just see which things land between that. So for instance, 0, 1, 2. So 2 is my number on my low bound, and then my high bound is 6. So 3, 4, 5, 6. So everything in between here are going to be the letters that are captured. As you can see, C, D, E, and F, which were printed right down here. So let's go ahead and as you can see here, this is basically what we just printed off, and we're going to go ahead and slice this a little bit further. You can actually slice a slice, and you could really go down the rabbit hole, but we're just going to do this once. So here we're going to we have our slice S, and we're going to go ahead and slice out a section of that. So we're going to take from the lower bound of 1 and the upper bound of 3. So this should print off D and E. There we go. So we basically sliced our array here with this slice, and then we sliced the slice even further to get these two letters. Now with the upper and lower bound, if you don't provide a lower bound, it's just going to use 0. So let's go ahead and print that. All right, so it's basically 0 to 4. So, and this one is from the letters array. So 0, 1, 2, 3, and 4. So we get A, B, C, and D. And same thing goes for the upper bound. If we don't provide it, it's going to use the maximum bound that we can use. So let's print that. And we get C, D, E, and F. So we start off at 2. So 0, 1, 2, 2, 3, 4, 5, 6, 7. And that gets us C, D, E, F, G, just like we see down here, C, D, E, F, and G. And as you would probably expect, if we do not give it a upper bound or a lower bound, it's just going to take the highest and lowest bounds, and it's going to grab everything. So there we go. We have a slice of the entire array. All right, now you don't actually have to slice a existing array. You can actually make a brand new array with make. So there's two different ways. You can slice a current existing array, or you can make your own array. Now it says it's making a slice. There's always an underlying array with a slice, so it's actually creating its own new slice, but it's still pretty handy. So basically, make, which is a built-in function of Golang, it's going to expect a type, a length, and a capacity. Don't actually have to provide capacity. If you just give it a type and a length, it's going to go ahead and set capacity to the same as the length. But anyway, here we have our slice A, and we're going to go ahead and make a slice of int with a length of 4 and a capacity of 8. So let's go ahead and print this. Okay, so we've made this, but we haven't actually set any values to it. So the 0 value for int is going to be 0. And before we go any further, I just want to say that if you make a slice and you don't actually put any values in it, the 0 value for a slice is nil. Just a heads up. All right, so let's go ahead and take a look at B here. So B is also making one. We're making a length and a capacity of 8, and that one printed off as well. So notice whatever we make the length, it's going to go ahead and put in that many 0 values. So this one, the length was 4. We got 4 zeros. Well, this one was 8. We got 8 zeros. Now we're going to cover append a little bit further, but I just want to show what happens when you add something to it. So basically, append is going to take the current slice B, and it's just going to go ahead and append this to the very end. And as you can see, it prints this off and it puts a 1 here. One thing to be aware of in this situation, since we set the capacity to 8, when we append something and you go past, you make your slice bigger than your underlying array, it has to remake that underlying array, and it's actually going to double the size of that array. So there's a little bit of a computational cost there if you're really looking for some bleeding edge performance. So just be aware of that. Anytime that you increase the size of your slice, it's going to go ahead and bigger than your underlying array, it's going to go ahead and double the size of your array. So it's going to have to allocate some more memory for that. Anyway, I hope that was useful. If you have any questions, just put them down in the comments. I'd be glad to answer them. All right, see you in the next one.